Hi everyone, my name is Li Qi, and our project is about predicting Dota 2 game outcome. So here's the motivation. Dota 2 is a free-to-play multiplayer online battle arena video game developed by Valve Corporation. There are total 110 playable hero characters in Dota 2. So for each team, the hero selection can significantly influence the game outcome. Professional teams recognize this importance of this, and in matches it usually takes up to 10 minutes for hero selection by both teams. So our project's goal is to predict the game outcome based on the hero selection. There will be 4 parts in my presentation. Data handling includes downloading datasets through Steam Web API and import and store data through Mongo database. As for data analysis, we use logistic regression and key nearest neighbors. In order to get a better view of our result, we use web interface. Here we use Flask web application. And for future challenge, of course, it's to improve accuracy. The first part is data handling. We download datasets through Steam Web API provided by Valve Corporation. After registration online, we can get our own private API key. Then we insert this key to Python script we create to start downloading matches. Here is a Python script we created. We can insert the Dota API key here. There are 3 requirements of dataset. The first is game modes. We need all pick, single draft, all random draft, and captain draft because in these game modes, every hero has the potential to show up in a match. The second requirement is the game level of the player is very high. We believe players with very high level can represent heroes at full potential. The third requirement is no players leave the match before the game is completed. The data for each match is structured as JSON. We totally download almost 60,000 matches through Steam Web API, and we use 90% of them to train our machine and the rest 10% to test our machine. You can see here is what our data set look like. We store this data in Mongo database. It's quite a lot. This is a screenshot. As for data analysis, one team is called Radiant and the other team is called Dire. There are currently 110 heroes in Dota 2, and the web API uses ID numbers range from 1 to 110 to represent heroes. We can see anti-mage is number 1, X is number 2. As for feature vector, we name xi equals to 1 if a Radiant player played as a hero with IDI, and we let x108 plus I equals to 1 if a Dire player played as a hero with IDI. Also, we like to let y equals to 1 if a Radiant team won, and equals to 0 otherwise. This is the first algorithm we use. It's logistic regression. Logistic regression is a model that predicts a bilinear output using a weighted sum of the predictor variables. A plot of our learning curve for logistic regression is shown below. We can see that the training and test accuracy are quite close together, indicating that our model does not overfit the data. The test accuracy of our model asymptotically approaches 70% at about 18,000 training sets, indicating that 18,000 matches is an optimal training set size for our logistic regression mode. This is a number of training samples and accuracy. The second algorithm we use is key nearest neighbors. We choose to implement key nearest neighbors in order to better model the relationships between heroes instead of simply taking into account wins when a hero is present. At a high level, we continue to focus on wins and the hero composition of teams. You can see the graph here. The test accuracy of model increases with training size up to nearly 70% for around 50,000 training matches, because we do not see the learning curve level off. This may imply that more data could further improve our accuracy. We can see this learning curve. So here's our conclusion. This is a screenshot of our web interface. We can see we can choose our heroes, and here's the opposing team here. Then we will get a problem how we win. So I will show you. This is the web interface. We can type the hero here. When we type first letter, we can get a list with names start with letter. Here, we can randomly choose some heroes. Then we will get a probability of the chance we win based on picks. This is 46%. Our machine has an accuracy of 70%. So that's all what I have done. Thank you.